Welcome back to the channel. As you know, I take simple code challenges and break down how I solve them. Along the way, I'll try my best to explain programming concepts that come up. Today, really simple one again, CamelCase word counter. The most important thing in trying to solve any programming challenge, whether it's a code challenge online or if your boss gives you something to do, you need to fundamentally understand what you're trying to solve. In this case, CamelCase, maybe not a word in everyone's standard lexicon, so you will have to make sure you know what that is. So let's Google, another tool in your tool belt. Let's Google CamelCase. So CamelCase looks like it's also known as camel caps. You write each word together, and then the next word or phrase is a capital letter. So here's the example. Here we go. CamelCase, lowercase c for the first word, and then case, the second word, uppercase C. And it's showing here, it's sort of superimposed on top of this camel. So it's showing the actual the origin of the word camel, and then actually showing an example of that. So that's what we're going to do today. And I have a few examples down here of what actual CamelCase would look like. So CamelCase here, programming is life, and then a good day for a walk. So these are all CamelCase examples, and these numbers to the side, to the right, I'll explain that too. The challenge is we're going to receive as input, as our parameter, a string of letters in CamelCase, and it will have at least one letter in the string, and it will contain up to 100,000 letters. So this, letting us know the constraints on this input, is very important. So they're not telling us this for no reason. We need to actually adhere to that. So at least one letter, perfect. That means it's going to be at least one word in here. We don't have to check for nulls, that sort of thing. And up to 100 letters. We'll get to that in a second. That's also very important. And then for the output, so I said I would talk about what these numbers are to the side. The output is the actual number of words. So it's a CamelCase counter, a CamelCase word counter. So over here, CamelCase is 2 words. Programming is life, 3 words. A good day, for a walk, 6 words. And notice that A is in here. Some of these can be very short. And again, this is very important that we have up to 100,000 letters here, because that's going to determine our data type. And we'll get there when we start programming. So the programming editor the IDE that I use is Dr. Java. So I already made a class here, and we'll just use a main method, a static main method, and we'll do that in here. And you know what? I actually will just return. We'll make a static method to actually return the value. So let's do that. We'll return an int, and we'll return an actual int, but I'll show you what could maybe trip you up if you don't use int, but maybe a different primitive data type. And we'll call this number of words. So a static int method will take one parameter of string. We'll call it words. And then in our main method, we'll just call this. And actually, so I can save it, I'll just return something. I'll return an integer. And then we want to print the value. I want to print something. And what do I want to print? I actually want to print number of words. This is a static method, so I don't have to instantiate this. So this is going to be CamelCase dot number of words, and then I need to pass my parameter. So, my parameter is words. So I'm going to pass some words in here, and we'll do one of our examples, CamelCase. paste that. Running this now, and running this now should not throw an error. I'm going to do some spacing so we can see what's in here. We'll compile it. It shouldn't throw any errors. Let's run it, and I should just get the value back of 1 because it's not very useful at this point. So when I call CamelCase dot number of words and pass in my single parameter, my string parameter, all we're going to get is 1 returned. That's not very useful yet. So what we're going to want to do is count the number of words, and there's going to be at least one letter. So we know that that's going to at least be there's at least going to be 1 word in here. So let's account for that. So let's make an integer. We'll call it, for instance, number of words. We call it word. No, how about word count? Int word count, and we'll default it to 1. There's going to be at least 1 word in here, no matter what. And then we'll return word count instead of a static value, just 1. So compile that. That should still be fine. Perfect. So with knowing that we have a string that's going to come through as our input parameter, we need to actually look at each letter and determine, is this letter the beginning of a new word? And a new word could start with just a capital A. That's all we need for a new word. But really any capital, so case is for words, for letters. This is a brand new word, but all we're really doing is looking for the capital letter. So again, a very simple problem. All we need to do is look for capital letters, but we have to loop through all the letters that we get. So let's do that. All right, that is how we would actually loop through our letters, but let's talk about it. A string is a string is an object, and what we can actually do with our object, our instance of a string that we call words, we can actually look through all the letters, and if we pull up the string, helps to spell it right, pull up the string class, there is an instance method called toCharArray that lets me convert this string into an array. I can loop through arrays. I can actually loop through and actually see every single letter, and the letters are actually going to be of the primitive data type char. So when I get to each letter, I'm literally calling it letter. I can actually see the letters that are in here and then do something with them. What I want to do is check to see, is this an uppercase letter or not? That's all I really need to know. Is this an uppercase letter? And if so, I want to increment. I want to say this is 1 more word in my string. So let's see if there's uppercase. And to check for uppercase, let's open Google again. To check for uppercase, we're going to use the character class in Java. And there is a static method here, Boolean, that returns true or false, that checks to see, is a character uppercase or not. Let's actually use that. So we're going to say if character dot is uppercase, we're going to pass in the parameter that it wants, letter, Then what we're going to do is say word count and then increment it with the unary operator to increment. And that's the entire challenge right there. So this was a very simple one. Let's compile it. Run it. When we run, we should get the value 2 to output. Let's run it. So we got 2. Let's try some of our other ones, our other CamelCase options or strings out here. Compile that. We'll run it. This should come back with 3. Excellent. And this one should be 6. Compile it and run. There we go, 6. So a few things to know here. Again, this was a very simple one. We had to know how to break a string down into an array of characters. We had to utilize the char data type. We had to use a character static method called isUpperCase. And we also had to use the we also had to use the unary operator to increment. I pointed out earlier that the 100,000 letters could potentially be an issue, and it could. I accidentally just solved it without even getting into that. But let's talk about that briefly, where you could actually run into an issue with this. So up to 100,000 letters, let's say, since some of these words in here are really small, that you could get up to, I don't know, 50,000. We would have to have a much larger string in here, but maybe we could have 50,000, 60,000 words if we really tried to. If we just had the letter A in here, there's nothing against that. We could actually have 100,000. So there's nothing against just putting the letter A in here 100,000 times and having that as our input. That would still qualify. It would still work. It wouldn't necessarily be CamelCase, but still, that could be our input. Why would that be a big deal? Let's actually come back to Google again. This time I want to look at the primitive types for Java. And let's take a look. Again, we'll just go to Oracle's docs. So the primitive data types, int is the value that the data type that I used, and it has it's a 32-bit integer, and it's a 32-bit signed integer, so I can use negative values or positive values. That's what that's what signed means. So I can use a ton of numbers here, and we can actually see how many that is. Let's open up just open up calculator. And we can see, so this is a 32-bit integer. So let's come out to the scientific calculator. 32-bit integer, but it shows here that there's a minimum value of -3 to the 31st, and then a maximum value of 2 to the 31st minus 1. So let's calculate that. How big is that? So if we do 2 to the 31st, that will give us 2,147,000,000, so forth. So a large number if I use an int data type. That will definitely account for up to 100,000 words, since I'm trying to return this integer. What if, though, I change this from int to short, 32,000? This is a 16-bit signed integer. Let's see how many, and it shows right here 32,000, but let's look at it. So this comes up with, it's just showing 32-bit, but we can still look at that as well. So let's clear this out. So that should be 30, clear this, 2 to the 31st. sorry, to the 15th actually. 2 to the 15th, 32,768. Is that what it came up with? It's actually it's -1, so 32,767. So that's as many values as it can actually represent. Now, I said, or this challenge said, up to 100,000 letters. If we decided to change all of this and use short, if we return back a short value, and our word counter here was a short data type, and we used short here as well. If we got to a point where we tried to increase our variable that is of a short data type, we would pass that and we would throw an actual error. So we wouldn't be able to do that. And I can even show just the error, and we can show the error that would occur. Short word count. And we can show this if we just try to put in too many, put in a value, a number that would be larger than it can actually hold. So we'll take this number and show that it can actually work. So we'll just compile it again. This should not throw any error. Short word count equals. Oh, you can't put commas in there. Compile it. Okay, so no problem here. This is a warning. It's letting me know that the word count is never actually used, but that's no problem. Let's actually get the error. I make this 1 digit over, compile this, and I should get a compile time error. It's letting me know that I can't convert my integer, which is this, to a short. So Java's actually trying to compile or letting me know that this is not a short value. This is an integer value. So I'm getting this error here. So if I tried my best to utilize that value and then eventually came to the point where I could no longer add values to that, I would get an error. So this also was very important, knowing this for up to 100,000 letters. That lets me know what data type I have to use to actually keep count. So again, that was a simple one, as long as you know a little bit about the data type that you needed to use, and again, just to reiterate, how to actually break down a string into a series of characters and then determine is a particular character uppercase or not.